Okay, I hope you enjoyed that video. It's a little bit out of date, but still, I don't think there's anything that as clearly shows how those different kinds of telescopes work. So the first kind of telescope is a refracting telescope, which functions by bending light using lenses. And you can see in this diagram that the light enters, and then it passes through the lens, and the lens makes it come closer together, and then it bounces against a mirror, and then it goes through some secondary lenses, and in the process it can flip the image upside down, which is why in that video from Mr. Wizard the images of the art book appeared to be upside down through a refracting telescope. Now, refracting telescopes have a significant limitation. By bending light with lenses the way that they do, they create fuzzy images, and that's called chromatic aberration. Chromatic means it has to do with color, and aberration means that there's an error that occurs. And so different light has different wavelengths. The red light is at the bottom of the visual spectrum that we see, and it has a much longer wavelength, and purple light has a much smaller wavelength. And so as these different colors of light pass through the lenses, they're not going to move exactly the same way, and they won't end up in the same places. So the relative positions between different colors of light will shift, and it's more evident with sharp lines in images. You'll see that they become fuzzy, and places where the color changes, the colors will end up in different spots, and that'll create a kind of a fuzziness here. And that's why in this picture here, you'll see the top image of the building is really sharp, and the bottom image is a lot more fuzzy, and that's caused by chromatic aberration. And so Galileo was the one that first invented this refracting telescope. Actually, that's not true. He stole the idea from some Dutch sailors who had used it to see things at a distance at sea, and he pretended that he invented it himself, and that actually got him in trouble. And that was one of the charges. In addition to things that they considered to be heresy, he got in trouble for stealing the ideas from the Dutch and claiming that they were his own. But his defense of that is that the Dutch, sure, they may have developed this device, but he used it for a whole different purpose by looking at the stars with it. And so by that he claimed to be the inventor, although he never gave credit to the Dutch originally when he stole that idea. So the reflecting telescope came much later, and this telescope doesn't use lenses. It uses curved mirrors, and light, as you can see in this diagram, comes into the telescope, and it reflects against that mirror, and that curved mirror gathers the light together. It shines against the secondary mirror, which reflects it to the eyepiece. And this kind of telescope was a game changer. It allowed us to do some observations that ended up in us identifying that we're part of a galaxy, that some of the stars that we see in the sky, many of them are part of the Milky Way with us, and then there's other stars that we can see, and things that look like stars that are actually galaxies that are much further away. And before we had this kind of telescope in I believe that was in the 1800s, just a couple hundred years ago, we didn't know that we were part of a local group of stars called a galaxy. Okay, now I'm going to have you watch another YouTube video. This is a TEDx talk from Perth, Australia regarding a radio telescope.